Welcome back to Gabversity, ladies and gentlemen, where facts care not about your feelings. It has been an interesting couple of days, and it is lovely to see everyone again while we sit in the sun and we say hello, bitches, as Pompous likes to say. So, don't forget our private videos on Patreon at patreon.com/realgabsmacked. And now we've got the Pompous store, which is live. Hey, welcome back, long time. Pompous store is on Facebook. If you go to facebook.com/gabsmacked and then click on the online store, I've only got 3 products and they're still in Australian dollars. Can't yet figure out. Hey, hello Logan. How do you calculate to win the lottery? Good question. Basically, you don't play. Did you know there is less chance to win the lottery than there are people on the planet? It's too funny. Which means that there are more non-winners of lottery, which is probably why it keeps going upwards. But good luck if you win. Basically, you'd have to be. It's interesting how it works, but yeah, you have to be lucky enough to be the one who would have won it multiple times in a row. So if the chance is 1 in 10 billion and there's only 7 billion people on the planet, that means you have to be 1 in 10 billion and another 1 in 10 billion and another one. Springtime in Australia, yeah, stunning. And this is Wagga. Wagga's different, way different climate to Sydney, way different. So today we're going to talk about 4-dimensional mathematics. I have won the lottery finding you, Gab. Dr. Sexy, you're way too kind, way too generous. I win it via multiverse. Deltron is funny, man. Does every country's lottery have same probability? No, they do not. And not every lottery has the same probability. But the probability is still so low that you have to basically be multi-people because it's less than there is a population. Can you attribute your genius to your childhood? Probably. But it was something born in me that my mum picked up when I was a kid. I couldn't talk much, but she noticed that I was creating the alphabet and stuff when I was 2 years old. By the age of 3, I was already reading novels. So she thought, I think this kid's a bit of a freak. And then I was fluent in 2 languages by 2.5, even though I couldn't speak languages at the age of 2. So stuff like that. Weird stuff. Anyway, so let's talk about maths in 4 dimensions. So when you read the book A Freaky Genius, let's get our freak on. We are similar. Hey. Is 50-50, you win or not. Hashtag bad math. That is too good. That is good, man. That's too good. All right, so 4 dimensions. So let's start with 1 and then build ourselves up. So if you guys remember, I was talking, we have been doing quantum wave functions with 1 dimension of space and 1 of time. Right? Do you use your genius to make lots of money? Now, unfortunately, I'm not really interested in that stuff. I've always been jealous of people who are interested in making lots of money. Never really did it for me. I used to have a access. I could have made millions of dollars, but I used to just give it away or give it to charities and stuff, which I actually thought was normal. Then I figured out is not normal. And if you want to see all of the sports cars and stuff that I used to rent out that I owned, you can go to Facebook. I think it's called Sports Cars and Motorbikes Australia, and you can see all the Lamborghinis and Audi R8s and stuff I used to drive, and motorbikes and things. But I used to rent them out and then use the money to help other people. Alright, so 1 dimension skipping rope. Okay, just imagine, hey, Cyanide's back. Alright, so just imagine you got 1 kid here, 1 kid here. There they are. Kids. Okay, right, and right in the skipping rope, right? The skipping rope, right? They're doing the rope, and the rope's going up and down. Hello, right? That's one dimension, right? 1 dimension, up and down, up and down, up and down. Hey, up and down. So that's 1 dimension, right? Hey, Boss Briggs, the team is here. So that's 1 dimension. Now, how are we going to make 2 dimensions? Well, 2 dimensions is along the rope. So now we've got forwards and backwards and up and down, right? That's 2 dimensions. Forwards, backwards, up and down. Okay, 2 dimensions. Now, what's 3 dimensions? 3 dimensions, a plane, that's right. 3 dimensions is the skipping rope can go up and down, forwards and backwards, and side this way. So you can have a skipping rope, like you can do this, like see how one kid's doing this with the rope, And so the rope actually goes around, and that way, that around is made, that around, she's beautiful, has a beautiful mind, actually, from far as what I can see. And very misunderstood growing up. So you've got this skipping rope going around. Going around, right, is actually going around is made up of ingredients, and the ingredients are up, down, forward, backwards, left, and right. Okay, all of the positions you need. Hey. All right. So all of those together make the circle. Hey, there you go. Soft drink. Oof, I don't like soft drink. All the positions, damn straight. All right, so that's 3 dimensions. Now here's a question. What's 4 dimensions? Well, 4 dimensions, you got to imagine it like this, and I'm going to imagine it in many different ways, right? But this is the first way we're going to begin. 4 dimensions is an infinite amount of those kids, right? Like an infinite, you know when you put a mirror in front of another mirror and it makes a whole infinite amount? That would be the 4th dimension. So each one of those would be a snapshot in time. Okay, that's how we imagine it as humans. But they actually all exist in mathematics all at the same time. Okay, if that makes any sense, they're all there, right? So, you know, the first skipping rope, goes around and around and around in 3 dimensions, or up, down, left, right, forward, backwards, right? So the wave is going like this, and it's going around and whatever. But then you have a whole series of those infinite amount of waves, right? All in succession. That's the 4th dimension. Okay? And that is what we're going to do in this mini series of 4-dimensional mathematics of quantum mechanics. Hey, Sprinkle and Booze, one of my favorite people in the world. Welcome back. All right. So now we're going to show you the mathematics of that. Okay. So if you guys remember, it sounds so chaotic. Yeah. Well, that's exactly what's happening in real life. It's not a topological 4 dimensions. No, that would be, once again, Abyss is way too far ahead, the man. One day I'm going to catch up to you, man. And then you'll be like, yep, and everyone else will be asking the questions. Too good. Not there yet. All right, so you could call it that. You could call it a basic disjointed topological 4-dimensional formation if you wanted to. All right, so remember now, let's go back to when we began. When we began, we had cyanide. Solve x plus 2, x plus 4 if you have 20 seconds. It is, good question. It would be, well, minus 2 and minus 4. Hands down. I don't know. X is minus 2 or minus 4. I already answered it, I believe. Yeah. I answered it in 3 seconds. What are you talking about? All right. So moving on. If you guys remember, cyanide was at the top of the cliff, and she dropped the rock, and it went. Exactly. All right. So that was that was the 3 dimensions, right? You've got the rock that's sort of coming this way, right? And then it comes down and it's moving across. That's the 3 dimensions, right? Now what we did was we said if the rock goes down, right, it's a sum of its potential energy and its kinetic energy, right? So I'm going to draw it for you again. Cyanide rock hits my car. Okay, so here we go. Here is the top of the cliff. I can't see what I'm doing. That was an easy one, meaning the roots of poly question. X squared plus 6 squared plus 8. Ooh, that's a good one. That one there, that would be x equals minus 6 plus or minus the square root of 36 minus 32 all over 2. Which equals minus 6 over 2 plus or minus 2 over 2, which equals minus 3 plus 1 and minus 3 minus 1, which is minus 2 and minus 4. Done. That's okay. So Alrighty, so imagine if we had, where am I? That's it. So I don't know if you guys can see what I'm drawing. Where's the freaking pen? Okay, so here is the cliff, and here is Cyanide at the top with her cool new short hair, which I'm going to draw up there. Okay, if this I beat you to the answer. Of course you did. My processing speed is not very good. That's the slowest part of my brain. So I would hope that you would be faster than me. Okay, and then, all right, and then she drops the rock, right? So, Acme exploding rocks. Okay, so this, right, that's coming down as a kinetic energy. Okay, right on Logan's car. Smoke weed every day. Too much stuff going on. And that is the potential energy at the top. Okay, so the potential energy, and then as the rock falls, it loses potential energy and gains kinetic energy, but the total is always the same. So the total, which equals the Hamiltonian, right, if you guys remember, we call it the Hamiltonian, equals P energy plus kinetic energy, and it's always a constant. This is always a constant, okay? But now we have a problem. What happens if there's energy going that way, that way, that way, because the rock is going on an angle and twisting around in a circle, because, you know, a cyanide is that good that she can spin the rock so it spins around and it's sort of going like around in a shape as it's going down, like she's that skilled, right? So then we have a problem, because we have the Hamiltonian like this. Here's a question: can one have potential energy in the absence of gravity? Yes, you have infinite potential energy, but very good question, my friend. Okay, so here, heat-seeking exploding rocks. That's this. Cyanide. Too funny. All right, so now, right, we've got potential energy this way, and in 3D that way. Okay, and we have kinetic energy this way, and in 3D. Okay, so now we have two lots of 3D, and this plus this, okay, so PE in 3D plus KE in 3D equals H in 3D. Okay, so this is now three-dimensional mathematics. Exactly, trigonometry. We're going to use trigonometry to actually turn these into one line and then add it up. Now, I'll show you what this actually looks like from now on. So, potential energy, okay, we now put that on top, because it's now called a vector, and a vector's in 3 dimensions here, right? You can have many dimensional vectors, but anything more than 1 dimension becomes a vector, right? And this is a 3-dimensional vector, okay? Because energy is actually a scalar value. Ah, yes. What we're looking for is the modulus. Yes, absolutely. Absolutely. And that's what trigonometry will do for us. Yes. So you can ignore what Abyss said, everybody, but Abyss is dead on. But that'll make sense if you've done university level mathematics. Plus, okay, equals, okay, equals the Hamiltonian. Now the Hamiltonian is actually a vector, by the way. Okay, it's this Hamiltonian is energy with a direction, which is pretty cool. Okay, so the initial mathematics is the same. If you guys remember, okay, what we're gonna do now, right? We're gonna imagine that we're gonna have a tug of war, okay? So we have here, right? Here is 3 dimensions. We have, right? Okay, this is 3 dimensions. Okay, here on the roof of the house we have Cyanide with her awesome hair. Okay, and down here we've got Abyss, right? Okay. And then over here we've got Booz and Byron. All right. And what they're doing is they are playing tug of war with a rope. Okay. So, oop. Cyanide left. This stuff is too elementary for her. That's too good. All right. So I got to go soon anyway, unfortunately. All right. So Logan is back. Okay. Now she's pulling the rope, and you're pulling the rope, and Booz and Byron is pulling on the rope. So she's like, "Give it to me," rah, and you're like, "No, I'm gonna have the rope." And also, Booz and Byron's pulling on one part of the rope too, right? So the rope is getting pulled on, all you guys, right? And the result could be anywhere. Yes, I'm winning. So what could happen is, let's say that, you know, let's say Booz comes in and is like, "Oh, kick, oh, your ass is full." So Sprinkle pulls the rope, and then the rope ends up looking like this, right? Because she's winning, the rope goes like that. All right. Now, this is still 3D. So she's over there. So what's happened is the rope is now bent outwards this way. Okay. Now, because it's bent outwards, that means, right, that the resulting force has to be this direction, sort of. Has to be something like that in 3 dimensions. But how do we find that? Well, we have to find the combined forces of everybody. So we got to find Abyss is pulling it this way. You know, Cyanide is pulling it this way. Okay, and then Booz is pulling it this way. So what we do is we pull out those we pull out those forces and rip them out of reality and stick them on their own. So what we're going to do is we're going to say, here's Abyss's force, here is Cyanide's force, and there's Booz's force. Okay, and then what we do, right, is we're going to, this is an introduction, by the way, then we're going to move these around to make them into a triangle. Okay, so this and this together, this and this together might make 0, right, in that direction. But let's take it and put it here. So that is actually made up of this, and that one is made up of that. Okay, so now let's put them all together. All right, so we can see that Abyss's one, right, is made up of one that comes down this way and one that goes that way. Okay, so he's got 2, one there and one there. And Cyanide has one there and one there. Okay, and then we have Booz and Byron, who's got one coming out flat and then one coming up that way. And now what we have to do is add all of these together to get one resultant force. Okay, so this one and this one, right, that will shrink this. Okay, so when you add this one and this one together, you get a smaller one here. Am I still winning? It looks like it so far. And then this one and this one cancel out, so that'll make it 0. And then Booz and Byron, that she's got a bit there and a bit there, so that goes a bit longer, and that goes up. So what's going to happen is the result is this part of the triangle. You see, that and that is going to pull that. So that's the net force. So in the end, it looks like the rope is actually going to follow this triangle. Okay, in 3 dimensions. So that's where the rope's going to go in the end. The rope is going to go that way. Okay, and that means that Booz wins. All right. So it turns out, because Abyss and Cyanide were fighting each other, it allowed Booz to actually win and beat them both. And there's a good moral to that. You see how, like, the 2 camps in the US are fighting each other? And so China will just be like Booz, come in and take the rope. So maybe Abyss and Cyanide stop fighting each other and work together. All right, so I'm gonna almost conclude this. I'm China, you're China. All right, now I'm gonna hang up on this scope and do another mathematics one, right? So this was the introduction, okay? And now that I've shown you the actual drawings of how that works, we're going to do it mathematically. And mathematically, it's just going to be a mathematical trigonometric version of what I just drew. Should be on the same plane to the origin. You should be, whatever plane you're on, 4D, that was a 3D representation. Yes, and then I explained the 4 dimensions at the beginning, and then I've shown a 3D representation. Now the next lecture is going to be the mathematics in 4 dimensions. All right. But if you saw the beginning, I explained how the 4 dimension looks using skipping ropes. Yeah, you're welcome. Irrespective of what plane you're on, as long as you're not net opposing each other, then you could beat booze together. So you'd have to somehow guide your vectors into the same part of your vectors, each be in the combined force opposing booze. Anyway, pleasure. I will see you guys very soon, and it's all going to be all maths. So if you're not into the maths, you're going to get really upset on the next lecture. I'll see you in 5 minutes. Facts, don't care about your feelings. See you soon.